Hello, this is a very short introduction to Arcadia and Capella. Arcadia is a model-based engineering method that is born in Thales in 2006 with the objective of transforming engineering practices. The mandate at that time was to define an approach allowing us to cope with the growing complexity of systems and industrial schemes. Arcadia provides the high-level objectives, concepts, and viewpoints. Capella is a graphical modeling workbench specifically developed for supporting Arcadia. It provides a notation and the diagrams. It also provides a wide spectrum of original productivity and analysis capabilities. The main goals of Arcadia is to understand the customer or user need, to define and share the solution among stakeholders, to secure system, software, hardware engineering, and prepare subcontracting, to early evaluate and justify architectural design, and finally, to prepare and master integration, verification, and validation. Most of Arcadia is summarized here. 4 main engineering perspectives with specific tasks or objectives. For each of them, an example, the concepts and description means are provided. The biggest takeaway is a clear separation between the capture of the need and the description of the solution. The core concepts of Arcadia are extremely simple. It all starts with capabilities that define high-level services provided by the system. What is the system or product able to do? Why is the customer buying it? Capabilities are described by functional chains and scenarios that illustrate specific usage contexts. For example, an end-to-end chain description of how the system is solicited and how it reacts. Functional chains and scenarios are used, for example, to capture nominal and degraded cases. A typical usage is to relate them to test procedures. Functional chains and scenarios involve atomic functions or actions that have dependencies between each other. A function produces outputs that are consumed by other functions. These dependencies are called functional exchanges. Functions and functional exchanges are located to structural elements such as the system itself, its constituents, or the actors. Functional exchanges are located to component exchanges. Functional exchanges and component exchanges can be further described with interfaces and data structures. Last but not least, mode and state machines attached to structural elements allow a behavioral description of the system and a specification of which function or interface is available in which mode or which state. To make all this more concrete, let's use a small example. Here, the product is a drone-based solution to inspect the exterior of aircraft. We start with operational need analysis, where we focus on what the users of the system need to accomplish. One of the goals of operational need analysis is to support the discussions with the customer. The operational need analysis of our product describes the stakeholders and their activities, the maintenance services, the certified inspector, the airline company, the aircraft captain, the infrastructures around the aircraft. We describe what the certified inspector does and show how the surrounding infrastructure constitute obstacles that can alter the inspection results. Operational need analysis is a great place to conduct value analysis and identify the pains and gains of each stakeholder. What is not relevant here is the exact boundary of our system or product. We shouldn't see a box representing it. The second Arcadia perspective dedicated to the need capture is called the system need analysis. Here, we focus on what is expected from the system. We formalize the result of a capability trade-off analysis, clearly identify the system boundaries and actors. Here, the functional analysis focuses on what is expected from our system. A function allows the drone to control its orientation and motion, whether via automated piloting or manual control. We expect the system to capture data on the aircraft, such as pictures, videos, scans, to process them, for example for automated defect detection, and to display them. We clearly identify the actors interacting with our product and the exchanges with them. What is not relevant here is anything that is related to the solution, how things work, which technologies, and so on. After the capture of the need, we are finally ready to proceed with the description of the solution, and we start with the logical architecture, or conceptual solution. Here, we focus on how the system will work. The goal is to provide a high-level description that can be understood by all the engineering stakeholders, meaning not only by the system architects. The first obvious information about our system here is that it is made of a base station on the ground and of the drone. Some major decisions are described here. Is the execution of the flight plan the responsibility of the base station, or is it the one of the navigation component of the drone? If it is the base station's responsibility, then there will be high expectations on the connection between the base station and the drone, in terms of bandwidth or latency, for example. This communication will also offer cyber attack opportunities. If the execution of the flight plan is performed within the drone, then more computing resource will be required, with an impact on battery life and therefore on autonomy. The goal of this level of description is to give all stakeholders the same basic understanding of the solution: engineering managers, marketing staff, product line managers, design authorities, safety analysts. What is not relevant here is which specific sensors we're going to use, which command device, which communication media between the drone and the base station. We don't necessarily want to have the detailed interfaces here either. We are now ready to move to the physical architecture, or finalized solution. Here, we will make hardware choices, decide between make, team, buy strategies, refine trade-offs, detailed interfaces. The physical architecture describes the finalized solution with enough details to produce unambiguous contracts towards downstream engineering teams. Here, we choose that the base station is actually made of a joystick and a tablet. We choose which sensors we are going to use. We specify the communication media and specify precisely the interfaces in order to guarantee a proper integration later on. What is not relevant here is the internal detailed design of each system constituent. This will be the topic of downstream engineering models that can be automatically produced by Capella. To summarize, Arcadia exploits the same concepts in all perspectives. Capabilities are described by functional chains and scenarios involving functions allocated to structural elements. The engineering objectives of each Arcadia perspectives are just different. Not all projects are required to use all of these perspectives. A precise analysis of the engineering objectives and the definition of the corresponding modeling strategy is a mandatory step at the beginning of each project. This is what coaching is about. You can have more information on public forums, webinars, and YouTube channel, or directly from the Capella website. Thank you for watching.